Today we will work on this BMW 3 Series. It's a 2016 330i B46 from what I remember, and the car been to a ton of shops in Orlando area, and it's in a disrepair state for over 1 year. So let me try to see if I can start it now. This car is starting but it's not running. There is an active short circuit on the engine control unit. So we have, oh shit, the battery is dead. So this is a good occasion to test my Asper X 3000 milliamp jump starter. So I will connect this here, positive to positive, negative to negative. I need to push this button. Let's see now. Let's try again. Oh, perfect. Okay, let's drive this car in the shop. So I made it in the shop. What you can see here, this was the actual state of this car. Let me disconnect my jump starter. So yeah, this thing, it's working. I'll put it here. So I diagnosed this car. I did some checks on the field. I disconnected a couple of plugs, but I didn't pull the harness like this. This was done by someone else, you can see. Even they cut wires. I think all the parts are inside of the car. Also, the accelerator pedal was unscrewed, removed. They cut the wires, they did some checks, but the way that they work on this car was a barbaric way of working on vehicles. Oh yeah, so I have parts here. That's a good thing. So from what I know from the owner, this car was in a specialized Euro shop here in Orlando over 1 year ago. They diagnosed this problem and they replaced the DME because there is a short circuit on a 5 volts line, an internal short in the DME. They replaced the DME, they charged the owner, they clone it, I don't know what they have done, and the car is doing absolutely the same thing. I asked the owner about the original DME, if he have it, and he told me he doesn't have it. I asked him, hey, call back that shop to take back your DME because I'm pretty sure that your original DME is fine, especially when you have exactly the same problem with a replacement DME. So your DME is fine. He told me, I tried to call them, but it's over 1 year and they don't have it anymore. So at this moment, at this point, let's start to diagnose it together. I will show you my steps that I will take, and I will try to diagnose to see what is the deal with that short circuit. First thing, I need to connect a battery maintainer, voltage maintainer on this car because the battery is dead. Plus, minus. Yeah, so you can see the battery is not maintaining voltage anymore. Let's resolve that. And after that, I will connect Tesa and I will scan the vehicle. So after scanning the car, I have a bunch of errors, but most of them are caused by that weak battery. So I will display the fault memories. I will take a look, crankshaft sensor, heat management module. So all these modules are disconnected from this network. They are unplugged because I told you I also worked and tried to see if I can find out something quick in a parking lot, but that didn't happen. So you see, DME supply 2 sensor system actuators, system 5 volts, voltage too low, and it's present, voltage too low. So this error is in the DME. The DME is in charge of providing these 5 volts. Also, we have a bunch of other errors. Let me go like this to have all the present errors on the top. Pressure sensor venturi nozzle, deactivation, terminal 15 for the battery. Accelerator pedal module, pedal sensor 2, signal too low, present. I think this is one of those cut wires on the DME. But first, most important thing is to save a report before doing anything else on the car. Next, I will delete the fault memories to have and work only with the present errors, because that will be way easier to calculate and quicker to calculate a test plan and to execute a test plan. Okay, so we ended up with 13 errors. DME, transmission and ICM, everything is green. So we have DME supply to sensor system actuator system 5 volts, voltage too low and is present. Accelerator pedal, rail pressure sensor, heat management module, coolant temperature sensor, accelerator pedal module, charge pressure sensor, charge air temperature, pressure sensor, venturi nozzle, cylinder head temperature sensor and crankcase, permanent SAE fault code stored because of those. And signal, let's see, let's show completely. Signal poor quality use, signal. So yeah, those two errors on the ICM and transmission are caused by the DME because of all these errors. Now let me see, I'm curious to see what is the service measure for this error. For example, measure in service. Let's see here. Check the lines and plug connection between the engine control unit and connected sensor. See wiring diagram. Second, measure the voltage at one of the connected sensors. See wiring diagram. If the voltage is less than 4.8 volts, disconnect the remaining sensors and measure the voltage. If the voltage increased to 5 volts, renew the respective sensor. Only renew the engine control unit if the fault persists or the fault frequency is greater than 3. Breakdown instruction if necessary, power loss, turbulent motor running or breakdown. And the effect on customer, malfunction indicator lamp and check control message. Okay, let me calculate a test plan because I need to see the wiring diagram and to work on that. So let's remember, we have a test plan for the accelerator pedal, charge pressure sensor, coolant temperature sensor, heat management, intake pipe pressure sensor, venturi nozzle, temperature sensor, high pressure fuel system. Okay, let's select, because ISTA give us the most important at the top, the second one, sorry, we'll select the second one. Sensor system supply 5 volts, we'll calculate the test plan. DME supply to sensor system, actuator system 5 volts. Again, we have the same information here on the details. Supply sensor 2, voltage too low, fault currently present. This is a good thing because it's easier to work with a fault that it's present. Let's select that one, let's go ahead. Check sensor wiring and plug connection, check control unit and test module. Let's say check sensors first, wires and plug connection. So supply of sensor system, actuator system current fault status. So on line 5V1, no fault. 5V2, fault stored, fault currently present, and 5V3 is the same, no fault. Let's go in the wiring diagram. Let's see what is the deal with the 5V2. So for this I will go here in full screen. I will extend this wiring diagram. So this big thing from here is the DME, digital motor electronic, and everything here are sensors. Inside of the DME, you see we have a branch here that will supply these branches for 5V1. 5V1 will supply throttle actuator, crankshaft sensor, engine oil pressure sensor, exhaust gas pressure sensor for petrol particulate filter, and half of the accelerator pedal module. The other half of the accelerator pedal module, the 5 volts, will be supplied by 5V2. So we have a problem. We saw that we have a problem on 5V2. Okay, go back full screen. So on this particular line there is a short circuit, and also we have the 5V3, but this line is again healthy. So from what I see here, the 5V2 will be provided by the DME to 3 different plugs. I know that because I can see here this pin for the accelerator pedal module, it's in plug A368-1B. These two supplies are on A46-2B, and the rest of them are in A46/3B. So let's see which plugs are these ones. So you go installation location. So you have in A368-1B, this is the accelerator module, and A46-2B and A46-3B are the second plugs for the other sensors that are on the DME. Okay. So from here we know that intake manifold pressure sensor, heat management module, rail pressure sensor, exhaust camshaft sensor, electrical wastegate valve, and on this side we have pressure venturi nozzle. All these sensors are supplied, they are in this 5 volt network. The test plan told us to disconnect one sensor, check voltage, and if we are low on voltage, disconnect the rest of the sensors until the voltage will return. If the voltage won't return back, that means there is a physical problem inside of the DME. So with that in mind, already we see we have here the venturi nozzle disconnected, the fuel, high pressure fuel rail sensor disconnected. This is the turbocharger pressure sensor. The heat management module is disconnected. Even here, this is the intake manifold temperature and pressure sensor. It's disconnected also. And this one, it's from the wastegate actuator from the turbocharger. So from what I see here from the get-go, everything is disconnected. But if you ask, hey, I don't know where is this sensor on the car, intake manifold pressure sensor, that is not a problem. You see here B439, if you click on that, it's blue, it's clickable, will show you the sensor and everything that you need to know about the sensor. You need to be too stubborn to not read this information here if you don't know nothing about that. And also we have here a tab with installation location. And installation location, you can see here B439-1B, it's here next to the oil filler plug. So like that you can find out every single module, every single sensor from here. You can know its location and how this sensor is locking. Next, let's see pressure sensor venturi nozzle. This one is the first one that we have here. In pin 3 we need to have 5 volts. And also let's compare it with what else we have here. I saw that the turbocharger sensor is disconnected and is not here. Charge pressure sensor. So the charge pressure sensor that was disconnected is not in 5V2, it's in 5V1. So on this sensor, it's pin number 1, that is the 5 volts. Oh, you see, sometimes you get that message. Component location. So this one, it's here, but what is this? Component description, sorry. Component location is this one. Okay, 311. So remember, pin 1, charge pressure sensor, and pin 3, pressure sensor venturi nozzle. So I say that charge pressure sensor, pin 1, it's a blue wire, yeah, it's this one, and venturi, pin 3. Okay, next I will use some pins to connect with that plug, with those plugs. So I have here some pins saved from different harnesses from BMW, and I will use those. I will probe in the front here and also in the front here. Now with my multimeter, I will go and select voltage like that. The negative one, we will use the throttle body. Let's make sure that we have a perfect connection, so I will connect to a screw on the body. And let's try to see on the turbocharger pressure sensor if we have 5 volts. Yeah, so we have 5.01. Awesome. That is 5V1. Now let's measure the 5V2. And 5V2, it's 0. Okay. So that means there is a problem in the harness or in the DME for that. Next, let me try to see, but before that I will switch off the ignition. I have switched off the ignition. Let me go in buzzer mode, in continuity. Okay, I will connect here and let me see on ground. Oh, we have here on the throttle body ground. So it's a permanent short circuit to ground. So from what we know from here, we need to disconnect all these sensors to make sure that the short circuit is not in one of them, right? Accelerator pedal module. Let's start with this one. B81-1B is the pedal module. Yellow with green from plug A3681B. A3681B is the first plug. So this is the first plug, because this is the plug that it's going inside of the vehicle. All the plugs from here are connected to the engine. Only this one is the one that is connected to the vehicle, to the chassis, to everything related inside of this vehicle. And I'm pretty sure, yeah, you see the color of this wire? Green, yellow with green. So yellow with green. Someone did a, I don't have words for that. They cut and destroyed this wire to do some diagnosis. You don't do that on a customer vehicle. You are not allowed to do, especially as a specialized shop, Euro repair shop. But with this here, we know for sure that the short circuit is not here. Next, let's go next sensor. Zoom out a little bit. Next sensor is intake manifold pressure sensor. Intake manifold pressure sensor. Let's connect this. It's the short circuit is present. Intake manifold pressure sensor. It's already disconnected, and we can see the pin blue. Let me see again. Blue with black. Pin 2. Next one, heat management module. Let me make sure that the heat management module is the module that I know it's a heat management module. So we'll hit here installation location, and it's down here. And it's that from there, and this is the plug, is disconnected, and we also can see here a blue wire in pin number 1. Let's go back here. Okay, close this. Pin number 1, blue wire. Next module, so these modules are in A46-2B. A46-2B is the second plug, okay. X46-2B. Next, rail pressure sensor, pin 3, blue. Rail pressure sensor is this one. It's already disconnected. The short is present. Pin 3, blue. Yeah, it's here. So that is disconnected. We still have a short to ground. Next, exhaust camshaft sensor. Exhaust camshaft sensor is this one from here. Okay, let's see. Exhaust camshaft sensor is this one from here. Let me unplug it because it's plugged, and the short is still there. You can see the blue wire. Give me a second, I will need to rescan the car. Okay, so we are back. We checked the accelerator pedal. We also checked the intake manifold, heat management, rail pressure, exhaust, electrical wastegate valve. Electrical wastegate valve, the same. Let me reconnect back my buzzer. It's short to ground. Electric wastegate valve is this plug from here, and the pin, it's one of those. It's blue. Yeah, it's a blue wire in pin number 2. And the last thing from here is the pressure sensor venturi nozzle. This one is it's in the same plug with these 3 modules. So the venturi nozzle is this one from here where we are connected. So with all the sensors disconnected now and only the DME connected, we have a short circuit to ground. At this moment, the specialized European shop that diagnosed this car, they are bingo, found the problem. DME, we have a short circuit to ground. Let's replace the DME. The only problem is after they replaced the DME, they had the same problem, and I'm dying to be there to see what they told the customer, what they lied to this owner about that problem, and especially how they could charge the customer for something that the customer didn't need, and the car is in the same state. At least if we had a different problem than before, yeah, we can say, yeah, that DME was a problem and we still have something else to work on. Either way, at this moment, probably most mechanics, specialist shops we will condemn that DME. But we need to make sure, because that DME is not a cheap part, it's quite expensive, if it's a news, especially it's a new one, and cloning a used unit is expensive. So we need to make sure that we will give the customer the correct and accurate diagnosis possible. Next step, from what we know from the diagnosis system for the wiring diagram, it's the 5 volts 2 network, the second channel. It's providing power to these 3 plugs. That means the first one will have that output 5V1 only on this pin for the accelerator module, and doesn't matter where I will measure the short circuit, we'll still have, we'll still have a short circuit to ground. Because even if we have different plugs, different pins, they are connected together, you see, they are connected together inside of the DME. So inside of the DME, there is a common bus bar that will connect all these pins. So let me connect back my multimeter to have that beeping constantly. So we are sure, we are very 100% sure that the short circuit is not from the accelerator pedal, that someone probably diagnosed that as being the main problem and that they cut the wire. And if we disconnect this plug, we completely separated that part of harness with the accelerator pedal, with everything, but even so we had this wire cut, so this plug was separated. Next, I will disconnect this plug. And when I've done that, my short circuit, it's gone. It's an open circuit, but, oh, don't jump the horses, wait a second. So we disconnected this plug, but we need to make sure that in this plug, maybe in this plug, the Venturi nozzle is connected. So when we disconnect this plug, we separated Venturi nozzle harness from the DME and the rest of the sensors. So let's see Venturi nozzle. Where is the plug for the Venturi nozzle? Pressure sensor Venturi nozzle. It's in A463B. Installation location A463B. So that means that the short circuit is not in the DME, because now we are measuring a direct short to ground in the DME. This plug is still connected here. So we know for sure, oh, my multimeter, like that. So we know for sure that our short circuit is in the harness, not in the DME. Now we need to find the short circuit itself. With that disconnected, that being A46-2B, A46-2B, let's close, oh, sorry for that, let's open it again, A46-2B. So in A46-2B we have only 2 sensors. One is the heat management module, and the second one is intake manifold pressure sensor. Nice. So that and that from there are connected in this plug. So one of those is shorted, but they are disconnected. Let me connect my pin here. So the blue pin, look how they destroy the wires, you see? They pinch the wire. You don't do that. You are not allowed to do that. So this, in the future, this harness is compromised, because that wires, those wires everywhere where they pinched the wire to measure, look, even here, to measure voltage, they destroy the insulation of the wire. Look, even here. They destroyed the insulation of the wire. Humidity, moisture will enter the copper wire will oxidate and will be an imperfect connection. So this harness, it's a time bomb, but that is not our problem now. So let me connect this in pin 2. Okay, let's make sure that it's in pin 2. Maybe we're measuring something else. Intake manifold, pin 2. So with this plug disconnected, we have a short circuit in the harness. Let me try to see. So the harness for the heat management module is this one. It's coming here. Look, they pinched here because that is the harness, and it's going down there. This harness from here, the same, it's going down there. Probably some of you already are screaming. You know exactly what is the problem here. Most of you don't know. I think I know, but let me show you, let me make sure that I am completely right. Give me a second to find a way to mount this light like that. So we say that, okay, it's enough beeping. We say that this harness, it's for the heat management module and is going down. You see it is moving. And this harness, it's for this sensor, but I cannot move it. It's very, very hard, very stiff. Probably it's tight with something or on the engine block, or maybe, let's take this guy, there is something else. So let's see, this is the wire for the sensor, this is the one for the heat management module. Let me see if I can go down there to follow this wire under the intake. Let's see if we can see something here. What is that? What is that? I'm pretty sure some of you will already know what is that and will be, wait, I know what is that. I think I know what is that also. Let me go down, because this camera is capable of doing a 360. So we'll go deeper and we will do, come on, we'll try to do a 360 to turn the camera up like that. And as you can see here, you see that? That is that harness. If I go even closer, if I'm not losing it, the harness is pinched. And I'm pretty sure that some of you already know what is happening down there. If you don't know, someone removed the intake manifold of this car, and when they mounted back, they didn't pay attention to the harness and they pinched the harness against the head and the intake manifold. This probably was done by a mechanic, by a specialist, or by the owner. We'll never know. The most important thing here is even if you have the same problem with the same error, that doesn't mean the problem that your car will have will be similar with this one. So please stop asking me, stop asking people online, hey, I have that P0 code, what is the problem? I personally don't know what is that P0 code. I'm not interested, I will never know, because I'm using ISTA. ISTA will translate that code, and also in ISTA so we have that test plan. Every single time when you have a problem, you need to do a diagnosis. You need to diagnose the car to make sure what is the problem on your specific vehicle. Doesn't matter if you have the same error code with this car, you can have a different problem. And as I told you, these DMEs will protect themselves. Every electronic module will protect itself against a short circuit. Doesn't matter if it's the light module, DME, or so on. So in this case, I'm pretty sure if I will repair that problem, if I will remove the short circuit from this network, everything will be perfect. So unfortunately, with this type of problem, the specialized Euro specialized shop from Orlando, they misdiagnosed it. I don't know why. Probably the technicians there are paid a flat rate and they didn't have time, or they didn't have knowledge. That's why every time when someone will ask me, hey, where should I go? Who I will need to find to work on my car, to diagnose it? And always I recommend to find a specialist, a specialized shop, not a mechanic. And here in the States, I've seen that everyone thinks that if it's an European car, being a Mercedes, BMW, or Volkswagen, Audi, they are the same. and they all go together to the Euro specialized shop. Unfortunately, the Euro specialized shop, sometimes most of them, they will scratch the surface. They will be very good at mechanics, replacing parts, but on diagnosis, and this one was a very simple one, but some complicated, they cannot do it. In Europe, there is a big competition between BMW, Mercedes and Volkswagen. They are totally different. They are 360-degree different. So it's very hard for someone to know absolutely everything about all these brands. So with that, probably I'm very sure, I'm confident that there are specialized people that they know very good to work on all cars, but most of them, they will scratch the surface, and in a case like this, they will misdiagnose it. And this misdiagnose was on a customer. The customer paid a lot of money for that DME to be replaced, and we still have the same problem. Now with this, I need to call my customer to inform him of what I have found. My job here was to diagnose it, and I will quote him for my labor to remove the intake manifold and replace the harness. And if he will accept that, probably you will see me how I will repair it. But also, on this car, as you saw, this harness is damaged. This is a time bomb. And I'm pretty sure I know exactly what will happen with this car. The owner will trade in this car, and you will never know where this car will end up. So in the future, I'm pretty sure the harness will start to suffer, and this car will start to have more and more problems with different sensors, errors, harness, and so on. And with the information that I have got until now, also I did a free visual multi-point inspection of its vehicle and added the recommendations for the future repairs. I've sent everything to the owner, and we will need to wait for its approval or denial.
The rest I will text you with more details about what I have found and what are the next steps.
And of course, he approved not replacement of the harness but repair. So now I will start to dismantle everything here to have access to the intake manifold, to be able to remove it, to assess the damage created by the ones that worked here before. Now I will start to disconnect the DME, the harness plugs. You can see the damage, the rat nest that they have created by messing around with this harness. I will take care of it, and I will make it look nice again. I need to remove the DME to have more access, more room. You can also see here some hardware misplaced by the ones that work here. Now I remove the tank vent system, disconnect the Valvetronic motor, and starting to unscrew the intake manifold. Also, I need to unscrew the duct for the air on the throttle body and the throttle body from the engine bracket. Of course, every single time when you remove an intake, you need to blow all the dust that can be found on the intake, because if you remove the intake and you have some trash dust there, when you pull out the intake, everything will go down inside of the engine, and you don't want to happen that. Now you can see here the damage. This wire was destroyed, was pinched between the intake manifold and the head. The wire is not cut, but was pinched so good that the wire shorted on the head. Now I have here some pigtails, different wires with the similar colors, and I will replace them. First I will cut the old ones. I will prepare the wires. I already soldered the new wires on the plug to be easier to work. And now I will start to connect back every single wire, color to color. There are only 4 wires, nothing to go wrong here. Also, every single time when I repair a wire outside of the vehicle cabin, especially outside of the vehicle cabin, everything should be soldered and used shrink tubing with gel to prevent moisture, humidity going on your repair. And also, when you solder a wire on a vehicle, always you need to have a flat plier to be able to flatten down the soldering job, because sometimes you can have some pins from the solder itself or for the wire itself, and when you try to shrink the tubing, those will poke to the tubing, and you don't want that to happen. After that, you can hit the shrinking tube to shrink the tubing. On the wire, you need to make sure that that special gel will ooze out from that tubing, then you will know that you have a perfect water-seal water connection. Now I will put back the remaining of that insulation, and also I'll use some Kevlar reinforced tape from Tesa. That is the tape that BMW always used, especially on outside of the cabin. Now I'll make sure that the harness is in its correct position. I will clean the head, and also I will replace the gaskets on the intake manifold. Now I can mount back the manifold. I need to make sure that everything will slide perfectly. I need again to double check the harness against pitching the harness, and now I can torque back the intake manifold on the engine. Put back everything, this time correctly, not like the last time, and start to reconnect the sensors, harness, vent lines, vacuum lines, and so on. And of course, I will repair the damaged wires that they've been damaged by the other people that worked on this car. Put back the caps that I have found laying around on the engine compartment. Double check to make sure that all the plugs are connected, secured properly, and nothing is pinched or damaged. Now I can start to repair the harness on the DME side. The same, I will cut the damaged wire. I will use a pigtail from a different wire. Don't forget the shrinking tube. I will solder everything back. And at the end, I will use my torch to secure the shrinking tube. And also, as always, use that Kevlar reinforced Tesa tape to wrap up the harness to make it look like nothing happened. Clean the DME housing, the DME bracket, and mount back the DME. After that, I can start to plug back the DME, the power module, IVM, plug everything back, double check to make sure nothing will interfere with something else. After that, I will reconnect the battery with my power supply, connect Tesa. You can see here the errors, most of them they are not present. Next step, delete fault memories. Meantime, I will do another visual inspection to make sure that everything is in proper order. You can see here there is some coolant leak. I will inform the owner about that. And at the end, absolutely no error. Everything is green. One single error, that is the permanent SE fault codes. That is a good job. So with this, now this car is repaired, everything will work perfectly. I hope you learned something new in this video. If you like it, please show me by hitting the like button. If you have any questions, but please don't ask me what is the problem of your car. If you have a different question, use the comment section down below and I will try to answer you. Thank you for being with me, and until next time, stay awesome. Bye now.